So here is a question for geometry that I've written here on the board. Some students, they say, hey JD, please help us with this question. So I've decided to present the working for this problem. So in this problem, we have a circle here with so many lines, tangents, chords, etc. So, and again, this line is a tangent to the circle at point C, and as we see here, BCE, angle BCE is 50 degrees, and also angle BAD is 68 degrees. Okay, and the question, we need to find angle CBD. Angle C, so at C, we go all the way to B, and then we turn all the way to D. So the angle that we want to calculate is this one. This is the angle that we are much more interested with. So how are we going to calculate this angle? Students, they normally panic when they see questions of this nature. Some students, they go to this point, they start to think, how exactly are they going to calculate that angle without thinking the theorems? So all what you have to do when you see questions of this form, relax, think of the theorems that you have learned under this chapter for circle theorems. What did you see? You see there is a tangent. What have you learned as far as the tangent is concerned? There are so many theorems, but most importantly, there are three theorems that you need to know as far as tangents are concerned. You need to know that where a tangent meets with where a radius meets with the tangent, the two are perpendicular. You also need to know what is called the tan chord theorem. That is the angle between a tangent, and a chord. This angle is equal to the angle subtended by the chord in the alternate segment. You also need to know the theorem that tangents that are drawn from a common point, those tangents are also equal in length. These are the three main theorems that you need to be familiar with when it comes to tangents. So in this case, we see there is a tangent here. So let's see which theorem here among these three theorems that you can use to find some of the missing angles. So we have a tangent here. Do we have any radius? No. So there's no way we can use this theorem. Yes, we have a tangent here. Do we have any chord? Yes, there is a chord here, chord BC. So 50 degrees is the angle between chord BC and this tangent. So the angle between this chord should be the same as the angle subtended by this same chord in another segment. So this angle is also 50 degrees. How do we know? We have applied the tan chord theorem. The tan chord theorem. The tan chord theorem states that the angle between a tangent and a chord here, which is 50 degrees, is equal to the angle subtended by this chord in the alternate segment. So yes, this angle is 50 degrees. Can we also use this theorem? No, there are no two tangents that are drawn from a common point. So this means that as far as these theorems for tangents are concerned, we can't use them any further. So we have to think of other theorems. So let's see, what do we have in this diagram? So as you see here, we also have this shape, a shape with four sides, and the vertices of that shape are on the circumference. We call this a cyclic quadrilateral. Remember, a cyclic quadrilateral is a four-sided shape with all the four vertices on the circumference. There are two theorems that we need to be very, very familiar with when it comes to cyclic quadrilateral. Theorem number one, we need to know that as long as if you have a cyclic quadrilateral, right, the opposite angles of a, let's say if this angle is A and this angle is B, we need to know that angle A plus angle B add up to 180 degrees, and also the exterior angle of a cyclic quadrilateral is equal to the opposite interior angle. So let's see if we can use that theorem here. We see we have a cyclic quadrilateral here, the angle here is 68 degrees, so straight away we can also calculate this other angle. How? We can simply say, for us to calculate angle DCB, which is this angle, is equivalent to 180 minus 68 degrees, because we know that this opposite interior angle of a cyclic quadrilateral are supplementary. So 180 minus 168, straight away we get 112 degrees. So this angle is 112. This is quite interesting. So if this angle is 112, therefore we can calculate angle CBD. How? We know very well that angles in a triangle add up to 180. If you have a triangle like this, and you know this angle, and you also know this angle, and you also know this angle, know that if you add all those angles together, all what you get is 180 degrees. So here, for us to calculate angle CBD, we can now say 180 minus 50 minus 112. And what do we get? What do we get in this case? Remember, if you say 180 minus 150, we get 130. And if you say 130 minus 12, we get 18 degrees. So yes, degrees. So yes, this angle is 18 degrees. Yes, that's how we handle questions that involves circle theorems. Look at a question, don't panic. Think of the theorems as they are classified into different groups. There are theorems that have got something to do with the tangent. There are theorems that have got something to do with the center. There are theorems that have got something to do with the cyclic quadrilateral. Play around with each theorem at a time until you get the result that is examined. That's all that you have to do. Awesome.